Hey everyone, today we're going to be going over the basic trigonometric derivatives. Let's start the video by identifying what trig derivatives we already know. So, in a previous video, I went over the proof for the derivative of the sine of x being equal to the cosine of x. But for the rest of the trig functions, the cosine of x, the tangent of x, secant of x, cosecant of x, and cotangent of x, we are yet to figure out what these derivatives are. But in this video, what I'm going to do is go through a couple of mini proofs just to try and identify what they are. Let's start by identifying the derivative of the cosine of x. And to begin this proof, what we need to do is draw a triangle with an angle x, an adjacent side equal to the cosine of x, and an opposite side equal to the sine of x. From here, we can use the Pythagorean theorem, and that'll tell us that the cosine squared of x plus the sine squared of x is equal to the hypotenuse. And using our trigonometric identities, we know that the cosine squared of x plus the sine squared of x is equal to 1. From here, what we want to do is isolate our cosine squared of x because we're going to solve for the cosine of x. So we'll have that the cosine squared of x is equal to 1 minus the sine squared of x. From here, we're going to square root both sides, which will leave us that the cosine of x is equal to the square root of 1 minus the sine squared of x. From here, what we're going to do is take the derivative of both sides, and since the derivative of the cosine of x, or since the cosine of x is equal to the square root of 1 minus the sine squared of x, the derivative of the cosine of x is also equal to the derivative of the square root of 1 minus the sine squared of x. From here, I like to do a little trick. Some people don't have to do this, but I just prefer to do it where I'll rewrite square roots into the power form. This is because since I'm taking the derivative, it just reminds me that I need to use the power rule. And since we also have to use the chain rule, it's just forcing me to remind myself to do the proper derivative rules. So from here, the square root of 1 minus the sine squared of x is equal to 1 minus the sine squared of x, all raised to the 1/2 power. Now taking our derivative, what we're going to have is that the derivative of 1 minus the sine squared of x raised to the 1/2 power is equal to 1/2 times our inside function, which is 1 minus the sine squared of x. Then this is raised to the negative 1/2 power because the power rule tells us that we have to subtract 1 from the power. And then using the chain rule, we multiply by our derivative of the inside function, which is going to end up being negative 2 times sine of x times cosine of x. From here, let's simplify a little bit. So our 1/2 times our negative 2 is going to leave us with a negative 1. And then our 1 minus the sine squared of x is also equal to the cosine squared of x. So what we have is that the cosine squared of x raised to the negative 1/2 power times negative sine of x times cosine of x is going to be equal to what we had before. From here, let's simplify our left part of the function. So we're going to have 1 over the cosine of x times negative sine of x times cosine of x is equal to what we had before. Now, let's bring this into one fraction. So we have that negative sine of x times cosine of x divided by cosine of x is equal to what we had before. And then our cosines are going to go, and we're going to be left with the derivative of the cosine of x being equal to the negative sine of x. Let's finish off our primary trig functions by finding the derivative of the tangent of x. So for this proof, let's first identify that the tangent of x is equal to sine of x divided by cosine of x. From here, let's take the derivative of both sides, which will tell us that the derivative of the tangent of x is equal to the derivative of sine of x divided by cosine of x. Now, what we have here is a quotient, so we need to use the quotient rule to figure out this derivative. So the quotient rule tells us that we'll have the bottom, which is the cosine of x, times the derivative of the top, which is also the cosine of x, and then minus the top, so the sine of x, times the derivative of the bottom, which is the negative sine of x, which we found out from our derivative of the cosine of x proof. Then this whole thing is divided by the bottom squared, which is the cosine squared of x. From here, let's simplify a little bit. So we'll have that the cosine squared of x plus the sine squared of x, all divided by the cosine squared of x, is equal to what we had before. Now, as we know from our trig identities, the cosine squared of x plus the sine squared of x is equal to 1. So what we'll have is that 1 over the cosine squared of x is equal to what we had before. And from here, we can rewrite this and say that the derivative of the tangent of x is equal to the secant squared of x. Now let's talk about our reciprocal trig functions, and to begin we'll talk about the derivative of the secant of x. So to start our proof, let's identify that the secant of x is equal to 1 over the cosine of x. From here, let's take the derivative of both sides, so the derivative of the secant of x is equal to whatever the derivative of 1 over the cosine of x happens to be. From here, again, I'll do the same trick as before, where I rewrite 1 over the cosine of x as the cosine of x raised to the negative 1 power. This is again because we're using the power rule, and it's just a little way for me to remember to use the power rule when I'm taking a derivative. So the derivative of the cosine of x raised to the negative 1 power is equal to negative 1 times the inside function, which is the cosine of x, raised to the negative 2 power, and then multiply by the derivative of our inside function, which is the negative sine of x. From here, let's simplify, so we have that the sine of x over the cosine of x squared is equal to what we had before. Now let's separate our fractions, so we have that the sine of x divided by the cosine of x times 1 over the cosine of x is equal to what we have before, and this can be written as the tangent of x times the secant of x, which is what the derivative of the secant of x is. From here, we'll talk about the derivative of the cosecant of x, which is a very similar proof to the secant of x. So just like before, let's identify that the cosecant of x is equal to 1 over the sine of x. From here, we'll take the derivative of both sides, so the derivative of the cosecant of x is equal to whatever the derivative of 1 over the sine of x happens to be. Again, we'll rewrite 1 over the sine of x as the sine of x raised to the negative 1 power, and now we can take our derivative a little more comfortably. So the derivative of the sine of x raised to the negative 1 power is equal to negative 1 times the sine of x raised to the negative 2 power, and then times the cosine of x. From here, we will simplify again, so we have that the negative cosine of x divided by the sine of x squared is equal to what we had before. Now we'll separate our fractions, so negative cosine of x divided by sine of x times 1 over sine of x is equal to what we had before, and this will leave us with our answer, which is the derivative of the cosecant of x being equal to the negative cotangent of x times the cosecant of x. To finish things off, let's talk about the derivative of the cotangent of x. So to start, we have that the cotangent of x is equal to the cosine of x divided by the sine of x. From here, we'll take the derivative of both sides, so the derivative of the cotangent of x is equal to the derivative of the cosine of x divided by the sine of x. Again, just like our tangent derivative, we're going to use the quotient rule here, and so what we're going to have is that we'll have the bottom times the derivative of the top, so the sine of x times the negative sine of x, and then minus the top times the derivative of the bottom, which is the cosine of x times the cosine of x. And then this whole thing will be divided by the bottom squared, so we're going to be left with the sine squared of x being in the denominator. From here, let's simplify a little bit, so we'll have negative sine squared of x minus cosine squared of x, all divided by the sine squared of x. From here, let's pull out a negative 1 from our numerator, so we're going to have negative 1 times the sine squared of x plus the cosine squared of x, all divided by the sine squared of x. And as we know, the sine squared of x plus the cosine squared of x is equal to 1, so we're going to have negative 1 divided by the sine squared of x being equal to what we had before. And to finish things off, the derivative of the cotangent of x will be the negative cosecant squared of x. Now that we've found all the derivatives for the basic trig functions, let's revisit our table. So, as we knew from before, the derivative of the sine of x is the cosine of x. Now we know from these proofs that the derivative of the cosine of x is equal to the negative sine of x. The derivative of the tangent of x is equal to the secant squared of x. The derivative of the secant of x is equal to the secant of x times the tangent of x. The derivative of the cosecant of x is equal to the negative cosecant of x times the cotangent of x. And the derivative of the cotangent of x is equal to the negative cosecant squared of x. Alright, well thank you guys for watching. I hope that this video was helpful and that you either got a nice refresher or you learned where the derivatives of the basic trig functions come from. Be sure to comment down below what you want to see in future videos, and until then, I'll see you in the next one.